Okay, welcome, and welcome to the people online. If you were listening in the session this morning, my talk was on number talks, and today we're just going to kind of expand on it, answer any questions that you guys have about number talks, and share some materials that I like to use during number talks, and maybe model some example number talk lessons. So let's start out with any questions that you have from this morning, maybe. The question is, what's the best time of day to do it? Does this still work? That's kind of the nice thing about number talks. There's not a preferred time of day. Number talks are kind of nice because you can kind of squeeze them in wherever you want. I personally prefer having it at the beginning of my math time, but sometimes we have schedules that are handed to us, and that's not always possible. So I know, like, I've come back from lunch and had 15 minutes before we went to PE, and so that ended up being a perfect time to have a number talk.
And how long do you do math after the number talk?
I'm from the state of Nevada, so we're required to do 70 minutes of math per day.
For TK?
Oh, for TK. Actually, yes. If it's full day program, we have 70 minutes in every grade level. Prior to that, we used to have some half days, and they were 35 minutes a day. So, I don't know if that helps. Sure. Other questions or from online?
The number talks, I know you talked about it being for, early elementary, primary age, but what about early childhood? Do you think a lot of the activities or ideas can be modified for like 3-year-olds or?
I think yes. But I think before they have number talks, they have to have a lot of hands-on. Their hands need to be touching and moving those materials themselves. And I forgot to repeat the question for the people that are online. The question is, are these materials appropriate for pre-K, or if they just need to be modified? So I think in pre-K they need a lot more hands-on. They need to be touching it, moving it. We saw in the presentation this morning from Dr. Frank that the kids need to have access to materials so that they can learn how to keep track and have one-to-one correspondence. And if everything's out of their hands, they aren't going to develop those strategies. So it's critical that they have that time. If I'm doing number talks with pre-Ks, it's going to be small numbers, small quantities, up close. I don't know what kind of class sizes you have in pre-K. What kind of class size do you have? How many students?
I would have a maximum of 24.
One teacher? That's a lot of pre-Ks. So another thing that we do with number talks is I like to have it as a whole group because it feels like a very community building opportunity. But it took me a long time to learn that you can also have a small group number talk, which can be also focused directly on the needs of that particular group of students. And Kathy Richardson used to come to Las Vegas 7 or 8 times a year for a week at a time, and I frantically took notes of everything she said. And one day she said, and you can have a small group number talk. And I was like, oh, that's brilliant. And I wrote it down, and then I went back in my notebook. I'm like, oh, she said that like 3 or 4 other times. But I wasn't ready to hear it yet because I was still figuring it out myself. And but if you have a group of kids that need a specific focused kind of number talk, then you can pull a small group. So in pre-K, it might be appropriate while they're working to have just a small group number talk where they're closer to the materials. If they need to reach out and touch them, they're close enough to them. And then again, keeping those numbers pretty small. Like, don't point me out. Any other questions? Any questions from online? All right. So I want to hand out. Who is helping me? Maybe. Yes. And this will be available to the people online as well. Thank you. So this might go back to that question from pre-K also. These are kind of 4 stages of working with models. And the first stage being, and it kind of reminds me of what our Montessori people were talking about, that concrete stage where the kids have to touch it and move it and manipulate it. And then number talks doesn't actually start until stage 2, and that's when I'm taking it out of their hands and holding it up front and asking them to look. And with those little ones, they're also reaching. Their fingers are out here trying to count. So stage 2 is when I'm holding up a model of some kind, and the kids are able to see the entire model. So for example, I might have these dots on a cookie tray, and my question is, thumbs up when you know how many dots. If I'm thinking about pre-K, it might be more like that. Thumbs up when you know how many dots. Okay, raise your hand if you want to share. All of the kids will usually share more than adults. And then we want them to talk about how they saw it. And if we're thinking about our pre-K kids, what are most of them going to say? They counted. And we can usually see them doing it. Their fingers are up. They're kind of touching them from a distance. Even in kindergarten, they're reaching to touch. So the nice thing the thing I like about the cookie tray and the magnets is that I can manipulate them quickly. So if this was my first arrangement, I might say, okay, I'm going to change it, see if you can figure out what I changed. And maybe I'll add one more. And thumbs up if you know what happened. Asking the kids to think about one more than the number before. So that would be stage 2, where I'm asking them to, the entire model is there in front of them. Stage 3 is when I'm imposing a what-if kind of question. Like, oh, you have this 4. How many would there be if I gave you one more? So now they have to imagine that other one and see if they can think about that. So I can increase the difficulty without increasing the number size, just by taking part of the model away or making sure they have the whole model to look at. And then stage 4 is going to be the symbolic level, where I'm using symbolic level problems, but I'm actually going to talk back to the levels that our Montessori people talked about, the inactive, iconic, and symbolic. And I generally talk about it as CRA, concrete, representational, and abstract. The concrete is the kids have to have them in their hands, touching them. Even this is slightly concrete, it's just that they're not moving them. Then when I move to pictures, I'm talking about representational. And then when I get to the symbolic, then we're taking the pictures away. So, sorry. Anyway, does that kind of make sense, those 4 stages of models? Again, stage 1 is not in number talks. That's the kids doing their math at their workstations or... All right, other questions? Any others? Okay, so I just wanted to show you some different tools and materials that I like to use for number talks. This has been a new find for me, the cookie trays, and make sure you get the cheap ones because they're the ones that are magnetic. The ones that are expensive, the magnets just fall right off. So how often do we get to spend less money? I like to keep one side blank so that I can do that kind of see what I did to change. Having a 10 frame, a double 10 frame, having the kids think about thumbs up when you know how many altogether, and what am I hoping that the kids will see? I'm sorry? The shifting, yes. That, oh, I have 2 more and that will make a 10. And if I do that, then I have 2 left over, and 10 and 2 is 12. So somewhere along the line, and I don't know if it's kind of not continuing, there was this idea that you always had to fill the top 5 first when you're dealing with 10 frames. But we want them to recognize that 5, but we don't want it to always be fill the 5, because I have lots of other arrangements that I can do with the the dots if I'm not worried about always filling up that 5. And then I'll tell you what happened in a kindergarten class. I gave them this problem, same one that we just did, and almost all of them thought that this was 10. And do you know why they thought that was 10? Because they're looking at the shape and as opposed to the quantity. So because it was rectangular and it looked finished, they all thought it was 10. And so that was an aha for me that we need to always be mixing it up. Nothing should be too predictable. If I hold up a card that has 3 on it, and I hold up another card that has 3 on it, and I hold up another card that has 3 on it, and I hold up another card, what do you think they're going to think? It's going to be 3. So I want to make sure it's not always 3. Okay. So this is pretty versatile. The other thing that I learned just this last year is 10 frames are a great tool to help kids get that 10-ness, but it can also get in the way. I was in a first grade classroom, and I had problems similar to this, and they kept pointing at the wall, and instead of being able to explain their thinking, they just said, because that's the arrangement that's up there. And so sometimes take the frame away. Give them the same arrangement, but take the frame away, because that becomes like their answer for everything instead of thinking about the quantity, if that makes sense. Okay. All right. So some of the other materials I brought, here's an example of the 10 frame arrangements, again without the frame. Sometimes it's holding up 2 different tools like these and saying, what do you notice? Anybody want to share what they might notice?
There's one more on the black.
There's one more on the black dots. Okay. The funny thing about little ones is I hold up this one and I'll say, see if you can use what you know about this one to help you with this one. And their fingers go, they just start over, like they're completely separate. And so sometimes just holding up 2 side by side, not even asking how many, but just saying, what do you notice, opens up the opportunity for them to look at the relationships. Because we want to get away from kids thinking that every problem is a separate problem. There's one of my pre-K ones. All right. The other thing is, sorry. We talked this morning about a range of kids in our classrooms, and that we want the number talk to kind of meet the lower level ones and the higher level ones. And the models provide access to kids who might not have access if I was only using symbols. So let's just try a little. We did the string with the 98 and the 98 and 298. Well, now we're going to back up to some smaller sizes. And thumbs up when you know how many squares. Just tell your neighbor. And so my next question is, see if you can use what you know about this card to help you know how many are on this card. Okay? And if I'm always putting it away, they don't remember. So I know that there's a routine in investigations called quick images, and they hold things up and they put it away. And that's fine for certain levels of kids, and not levels, but ages of kids. But if you put it away, they don't always remember, especially with our little ones, our pre-K and our kinders. So I still hold this one up and say, see if you can use what you know about this one to help you know how many are here. And what's my hope? Just one more. They don't always see it. Sometimes I have to do something like this. Okay? Okay, watch what I'm going to do. Now how many? And I'm trying to focus their attention on the part that they already know, and then, oh, that's just one more. So these are actually fun for the kids to make. If you ask them to make arrangements on in a station, you know, make all the pictures of 5 you can, or make all the pictures of 4 that you can, and then choose a couple to glue down And it's amazing when they see their own work in your number talks. It makes them feel like it's theirs. And I was thinking about the picture that Kristen used of the car that was a rental car, and they were all scrubbing it. When the kids see their own work, they have ownership, and then they want to participate. So, all right, the Toothpick Cards, very similar. All of them have the same purpose, and that's to help kids build relationships between numbers. So I might have 2 cards that look like this. I don't always start with the one that has less. I sometimes start with the one that has more and hope that they see one less. One less is always harder than one more. But if I want to bump it up, I can always throw out thumbs up when you know how many altogether on both cards. That way, if I have those kids in my class that are thinking about bigger groups, they have an opportunity, and the rest of them are going to go 1, 2, 3, 4, 5, 6. So they're going to count. So they still have access because the model is here for them. Okay. This is just another tool. It looks, everything that looks different, they think that they're doing something new. Kids are easy to fool that way. So it might be the same arrangement that we just did on toothpicks or on dot cards or on my cookie tray, but now all of a sudden it's squares stuck together. And again, I'm wanting my kids to think about those number relationships. I might do something like this, because that one looks like this one. I might even do something like this so they can see both together, wanting them to know that's 5, and then sliding it away. Now we're looking at 2 more. And then what can I do with both? How many altogether? So my kids who might be able to think about doubles, and 2 more, it's there. And if everybody goes 1, 2, 3, 4, 5, then I know my quantity got too big, but they still had access. So access is a big word. I keep saying it over and over again. We want all kids to have access to the problem. And I had a friend who was doing number talks in her classroom. She was a first grade teacher, and she had this one little girl that could not see more than 4. So no matter what it was she held up, she said, I want to see how many 4s you can find today. How many 2s can you find today? She brought her in by asking the right question for her. And you were talking about formative assessment. Number Talks is also a tool for formative assessment. I'm continually watching what my kids are doing, and I'm making instructional choices about what I'm going to do next based on how my kids are responding to the questions. So something else, starting small. Oh, now how many? Now how many? So just unfolding them so that they can see if I know this, then 1 more and 1 more. I know I used to beat my head against a wall trying to get my kids to count on, like it was the big thing to do. And when we started doing materials, even though these were representational versus the ones that they'd be playing with in their stations, all of a sudden, oh, I already know 4, 5, 6. So counting on became something that was a lot easier for them to see because you were intentionally providing the opportunity to see it. This has become one of my favorite tools lately as well. For my younger ones, for my pre-Ks, it might even be something like this. Okay, thumbs up when you know how many cubes are on how many cubes. Thumbs up when you know how many are in my tower. I'm still going to have lots of kids that are going to go 1, 2, 3, 4, 5, 6. But I'm hoping what? Somebody's going to see that double. Okay? Depending on the group, if I want them to think about how many if I already know that this is 6, can they figure out how many are in this tower based on how many are in this tower? So I do it in 2 different ways depending on my kids. If my kids don't see it, when I put up something like this, it's a whole new tower, then I try to make it more visible to them. So if they don't see it when I do this and it's just all 1, 2, 3, 4, 5, 6, 7, 8, then instead I'm going to use a tower where I have that 6 highlighted that they already figured out, and then the two more is more obvious. But I don't always want to start out with the most obvious, because if they can do it without a prompt, then they can do more. So does that make sense? And then what would my next question maybe be? How many altogether? And again, there's that opportunity for a double if they see it. And if they don't, if the number got too big, then my little ones will start counting again. So no matter what, they still have access. Even if I say, if I have a child in my room that I know can't count past 5, I'll say, how many red cubes? Thumbs up when you know how many red cubes. And then that child has access as well. Let's see.
What is that little thing?
This is a 100 base Unifix cube board, I think it's what it's called. And it's available on Didax, but you can buy one for $10, or you can buy 10 for $25. So go in with somebody. All right, so that would be for my pre-K, K, first grade. I might be doing some things like this with kinder and first, where we're looking at combinations. Thumbs up when you know how many are in my tower. I want to arrange it in certain ways that they might use different. I might see this, the double, and then 4 more. Or somebody else might say, well, I have 4 and 3 green, and then 3 more red. So I'm trying to arrange it in such a way that there's more than one way to see it. Number talks are revolve around the idea that there's more than one way to see it. If there's only one way, then there's no conversation. So that's why we want to make sure that the problems that we're choosing allow for that variety of ways for kids to see it. I'm just going to do a problem here. Actually, I'm not going to use that. This is kind of bumping it up just a little bit. Thumbs up when you know how many cubes are in my towers. Okay, raise your hand if you would be willing to share. 38. And how did you know there were 38?
Because I see 3 equal columns of 10.
Okay.
And then I noticed that the 4th column only had 8.
8. So you used kind of a -2 here. Okay. How did you know for sure that those were 10? Experience. Okay. So I'm actually going to highlight that that's why I did one tower with an arrangement, because I want my kids to always verify. And I know you knew that I was thinking of 10s and 1s, but what if I had done this? It kind of looks like it. And if the kids aren't looking, it's kind of like my 8 on the 10 frame, where they're looking at the shape of it and assuming. So I always want to give them some place to verify that they actually do have 10.
I actually counted it, the one that's multicolored, because it's too hard for me to count the solid ones. I can't maintain where I am in my counting because
Yes.
I can't touch it.
Because it's a distance
Too far
away.
away.
Absolutely.
But when the colors were there, it was really easy for me to count.
And
And then I used that height, like you said.
And then match them. Yeah. So that's another good reason why you want to have one, because if it's away from them, out of their hands, it is hard for them to keep track. The other thing that happens is the only way they can verify is by counting. So I'm not even giving them another option. But by having a tower that has some intentional groups on there, and I try to think of different ways to show it, but what are some different ways that kids might see that 10? 5 and 5? Okay. Any other way? 3, 3, and 3. And it's amazing how many kids know 3, 3, and 3, even when they're little. I heard somebody else. Somebody say something about 6? No.
6 yellow.
6 yellow, 4 blue. Okay. So again, it's multiple ways to see. And then I'm going to put my cube back there. So what do we have again? 38. All right, so. Nope, sorry. Thumbs up when you know how many cubes altogether. Okay, this is why I love the thumb, because there's nothing more stressful than seeing 4 people with their hands up, and you're like, I haven't figured it out yet. So the thumb is just so powerful, even in reading, not just math, but that think time, and it keeps me on track for remembering think time. I'm not calling on the first hand that's in the air. So one thing I left out is we didn't figure out how many were here, and I could have written this as a problem on the board along with the model. So, and I don't know if this exactly ties in with the transference you were talking about, but if I have the model and then I'm going to write the equation on the board, then hopefully when the symbols and the models are together, they'll have a little bit of that transference. Okay, so what did you get? 55. Want to share how you did it?
I put the 2 top green ones over with the orange, and then I knew they were all 10.
Okay. So that whole idea again of making another 10, and then you have another 10, and then leftovers. Did anybody else do it the same way? Yes, you did. Anybody do it a different way?
I added the 2 that were not 10.
Okay. And what did you get? 15. And then what?
And then I added the 4 10s.
To the 15?
To the 15.
So you got 55. And then, sorry. This is one of the 4 10s. Okay, gotcha. So you did add the 3 10s and the 1 10 together first to make that 4 10s. Okay. All right. And this, does anybody want to take a shot at why I arranged this the way I did?
We needed the 2 if we were going to use it over there, but it also left 5, which was a nice number
Arrangement.
for us to hang around afterwards.
Yeah. And so in my head, my plan for my kids is to make it visible for them that they could make another 10. Is it okay if they didn't? Absolutely, because they're coming to the table with the math that they're using. And so I have something in my mind, but my kids aren't all going to do that. But I'm just giving an opportunity to notice. And if they didn't notice today, then I might give them another opportunity tomorrow. Oh, let's try another problem. If you were to look back at your stages of models, which stage am I at right now? Anybody? 2? What makes this 2? Okay, so it's not in their hands, so it's not 1. What makes it 2 over 3? Both parts of it are here. Everything is visible. Okay? What would I do if I wanted to bump it up a level and make it a level 3, a stage 3? I could take these models away and say, okay, you have this 38. How many would there be if I gave you 17 more? And can they think about adding that 2 or combining the groups of 10s and combining the ones like you, both ways that you guys did, but they have to imagine that second set. So stage 2, stage 3. This has become one of my favorite questions recently. This came up in a 2nd grade classroom. I was doing a number talk, and we do a lot of takeaway subtraction, but it's rare that we end up doing some comparison subtraction unless we're just comparing. So I was in a 2nd grade classroom, and we talked about how many more are in this than this. And they shared their different ways, and then one of the kids said, just with this look of aha on their face, and said, "That's why you can subtract." I was like, "Tell me what you mean." He said, "Well, all you have to do when you're finding out how many more is find out what's the same first, and then what's different is the answer." So he said, if you take the 2 10s away, and then you take a 9 from this side, and he took it out of the whole 10 and put this one back, then he said, the difference is, what's different is the answer, which is not true when we're doing subtraction. The answer is the difference. And but it was the models that gave him access to that thought, because oftentimes we teach subtraction, comparison model of subtraction is just subtract. But it's not really. Subtraction isn't, to take away is an action. And when we're comparing, it's not really the same thing. So anyway, the model gave him access to that idea that when you're comparing, you're finding out what's the same and what's different, which is when we're doing graphing and those kind of things, we automatically do that. But oftentimes we teach the kids, when you see a comparison problem, just subtract. And they don't know why. So, all right, let's go back to this. Let's say I had that 38 again. So the first time we had a full model, I gave you another. Sometimes I can say, what if I added so many more? Sometimes I want to think about missing addend. I have this 38, but I wish I had 50. What would I need to do? So there's your question. And that missing addend can only be stage 3 because I don't have what's missing, right? So I have this 38. What would I need to do if I wanted to have 50? You got it? Okay. Tell your neighbor. Okay. Who would be willing to share? Anybody? Thank you.
Add 2 to make that one 10.
Okay.
And then that's 40, so you would need another.
I need another 10. Okay. So again, the model helps them see what's missing. The further away the number is, the harder it gets. So I gave you 50. What if I had given a second grader 90? They have to think about a lot more missing quantity. I have this 38, but I wish I had 62. So now they have to think about what's missing to make another 10, how many more 10s I need, and then there's going to be some more leftovers. So I can bump up the level of difficulty by just changing the number a little bit. I have this 38, but I wish I had 29. So now I have to think about how many to take away. Okay. I talked this morning about the structure of our number system, and we really need kids to see that structure, and I know that's what you guys are working on too, the structure of our number system, and the models really help them. If I can add numbers, 2-digit numbers to 2-digit numbers, then 3-digit numbers and 3-digit numbers is just some more hundreds. But the hard work is really with these 2-digit quantities. Yes?
So before they get to this point, would you work with them on just making 10, like what numbers make?
Absolutely. Yep.
That they can automatically do kind of what
Yes. So all of that comes here when we're making a 10 and some more. How many? For this? Sure. Yeah, you could just have that one. Okay, or yeah. So I might want it to be more obvious, having 2 parts. It does make it harder to see. However, if I do this, it's easier for them to see the quantities, and they might have an opportunity to add a smaller pair and then put the rest with the 10. So even though it's in 3 chunks, I could see this double makes 6, and 6 and 4 make 10. I might have some kids in my class that can't do the bigger problem, but they could at least do the 3 and 3. So they have access at different levels. Okay. Some teachers have used these in a small group like station and doing things like what you were just saying. Show me all the different ways you could make 10, or show me all the different ways you could make 5. and they just stack them. And you don't have to have this to do that. You can just do it in trains. So thank you for that question. All right. Just going along the whole idea of keeping with the structure of our number system and how those basic facts to 10 and including combinations of 10 help you with everything from here on out. So some of the materials that I work with. And hopefully they can see these on the remote. These are just hundreds grids that are shaded in different ways. So here's a 70, here's 170. How many more do I need to make 200? What if I gave you 60 more? These I would obviously put on an Elmo with my students, but these are the exact same questions I use here and here, but now I'm looking at making the next 100. They're the exact same numbers over and over and over again. That's why these small numbers in the primary grades and pre-K are so critical, that they have lots of exposure and good experiences with those small combinations, because they're the same ones they use over and over and over again. If I know that 3 plus 3 is 6, and I come up here at this 170 and say, how many would there be if I gave you 60? Well, 3 of those 10s could go here and 3 more. So they're the same numbers that I'm composing and decomposing all the way through. I know that you heard me talk about. Yes, please.
So the one that isn't all filled in, are they counting by tens? I mean, how do they know it's 70?
Well, hopefully, at the point that I'm using these, they will know that when it's full, it's 100, because it's a 10 by 10. So this one is missing 3 10s. So it would be 70 because 30 is 70, yeah.
Now, are they able to do that, or do a lot of them have to count by 10?
At first, some of them do have to count by 10s. And even because you have such a varied group, some will still need to count by 10s. But eventually, if they've had all this background building up to it, and they're looking at combinations over and over and over again, by the time I'm showing them these, they've had experiences at their table. Because remember, I'm doing number talks at stage 2 and beyond. So prior to this, they've been working with these materials at their tables, in their stations, and building some background.
So when do you introduce the symbol?
Kind of all along. I try not to write on every single problem because it takes up time, and I have this much time for my number talk. So, and I don't start writing really until they are doing some kind of action. So when they're counting, and you counted 6, and you counted 6, and you counted 6, I'm just going to be writing 6. So I really don't do too much of that until they actually, some people like draw a hand, 2 hands, and go 1, 2, 3, 4, 5, 6. Again, that takes time that I could be asking another question. And so when they start doing something, combining, separating, that's when I start writing. But then I try not to write every day. Something else that I'm glad you brought that up too, because some of that algebraic writing that we should be doing, that it doesn't always have to be 3 plus 3 equals 6. Sometimes if they say, oh, I knew it was 6 because I know 3 plus 3, that's when I can write it the other way. 6 equals 3 plus 3. So number talks is a great time to change the way I'm writing it sometimes. This was a perfect example of that as well. I don't know where I put my 4. You guys can visualize my 4, right? The what if? Oh, here they are. So if I had, I wish I had a board to write on, but if I had a student who said, I knew that was 12 because I changed it to a 10 plus 2, then I might say, so you're saying 8 plus 4 equals 10 plus 2? So there's that standard that talks about equality. So I can incorporate that in as part of my symbolic writing. So that was a long answer to your question. But yes, the symbols come, and I want to attach it with meaning to the materials that we're using on an ongoing basis. And I want to record, and the older the kids get, the more I want to make sure I record at least 1 problem a day. And I try to think about which one's going to be eliciting multiple responses so that I have different things that I'm writing up. All right, going on from there, you heard my woes of middle school. I literally was going to quit after the first month until I realized they were 6-year-olds in bigger bodies. And I'm like, oh, I got this. But I realized when they couldn't do 8 plus 3 as an 11-year-old, I'm like, wait, what happened? Because my first graders could do this, and you guys are counting on your fingers. But I can't pull out my dot cards because they're 11, and they'll look at me like I'm nuts. So my answer to that was a thousands grid that looks like a 10 frame, but we're dealing with 1,000, but I'm just not shading in 100 of them. And so when I hold up this one along with a 500, do they know that one of those hundreds can go and fill that 1,000, and then I have 400 left? So in the end, they're still working on their basic facts. It was my sneaky way of pulling in the basic facts, but making them think they're working with bigger numbers, because they were.